So let's practice adding JAL and JR to this. So here's our data path, and we're going to add JAL and JR instructions. So what do you need to do this, and where does it come from? So to help you out here, let's take a look at some of the details of JAL and JR. So JR, jump register, just goes to a register. And it's going to take the address in the register, and it's going to go to that address. Jump and link is going to go to the constant we have here and take the next address and store it in the register file. So let's take a look at how they're encoded. So here's jump and link, and if you look at what it does, it says register 31 is going to be the next PC, and it says the next PC is going to take the current PC, clean it up so that we don't have any bits in the lower parts, then OR in the target. It's going to replace the target into the lower parts of it. The target here is the immediates that we have in the instruction. So what format is this instruction? Well, if you take a look at it, we've got this really long immediate here. This is an J format instruction. R31 isn't specified anywhere in here. It's hard-coded into the instruction itself. If you take a look at jump register, what we can see here is that the next PC gets the value from the register, and that's the format. So what format is this? Well, it's an R format. It specifies one register and no immediates, but you can use any register for it. All right, so what do you need to add, and where does it come from? Well, for jump and link, you need to do a few things. You need to take the next PC and put it into the register file. You need to take the immediate from the instruction and put it into the next PC. And you have to have a mux so that you can control what goes into the register file and what goes into the next PC. For jump register, we need to have the register file go to the next PC, and we need to have a mux that allows us to control the next PC. And where does this stuff come from? Well, for JAL, we get the next address from the PC, the value we're going to put in the register file, and we get from the instruction immediate, the value we're going to put in the next PC. And from jump register, we get the next value for the PC from the register file. All right, so go ahead and change the data path to support this. What do you need to add? All right, so let's walk through this. So for jump and link, we're going to have to add a wire. So we're going to add a wire here, which is going to take our next PC, and it's going to allow us to write it into the register file. We're going to have to add a mux here, which allows us to control this, because remember, we need to be able to write back from the ALU or the memory, as well as now write in the adder. So we need another mux to control that, and we need some control logic from the control here to choose from that mux. We also need a way to set the write register. Remember, jump and link is hard-coded to write into R31, so we need to add a mux in here, a value, so that our control signal can say, when I'm going to do jump and link, I'm going to always write into register 31. Now, we need a wire for jump register. We need a wire that we can take the result out from the register file and put it up into our next PC. We need a mux so that we can go ahead and choose between that and our other jump options. And we need a control signal, which will allow us to control that.